see what's happening. There we go. Okay, so I'll make a few examples here, not too many. Let's say first one is convert 0110 to decimal. 2 is convert 25. Okay, let's make it maybe 20 to binary.
You just need to keep getting.
Yep.
Why is there more private? The button is short. Okay. Look. It's majority. Typical bullying. Sure, but that. Oh, my God. Oh, yes. Yeah. It's not safe. Yeah, I hope then. Huh? It's yeah. No, it's not extreme.
You guys good? Sorry? Number three, yeah, I'm going to explain that one because the first two are a bit more simple.
Yeah.
You guys good with 1 and 2?
Yes.
Okay, perfect. So number three was this thing where we did this kind of three-step method to convert something to binary using 2's complement. So we'll go over the three-step method. So the number we're converting is -1. The first step, I'll write it here, step 1, is to convert 1 to binary. Forget about the negative sign. Just worry about the positive part of the number. So step 1 is to convert 1 to binary. Right, I gave you an easy one because 1 in binary, we know it's just 1. Right, we usually use a standard of 8 bits. So I'll write it using 8 bits. That's 1, 2, 3, 4, 5, 6, 7 zeros and a 1. So that's 1 in binary using 8 bits. Right, we always use a standard of 8 bits for this question. Step 1. Step 2 is to invert all the bits. So zeros become 1s and 1s become zeros. So that is just inverted. Right, and the last step was to add 1 to this number. Step 3 is to add 1 to this number. Okay, and of course, we know there are two ways to do this. You can do it by intuition. Adding 1 is the same as counting to the next number. We can do that, or we can do the more formal method. So first, I'll do the intuition method. I'll write it here, 1, 1, 1. Plus a binary 1 is, that gives us, so that's the intuition method. If you don't like this method, you want to use the more formal method. You can write it like this. So take the original number, which was 1, 1, 1, 7, and we add 1 to that in the old-fashioned method. Write it like this: 2, 3, 4, 6, 7, 1. That's another way you could do it, right? So I think we've done this before with this class. Yeah.
Yeah.
We've done this. Okay. It was just a quick recap then. So 0 plus 1 gives me 1. 1 plus, all the rest is going to be 1. All the rest are the same. It's just 1 plus 0, which is all 1. So this entire thing will just be 1s everywhere. So that at the bottom is the answer. So -1 for the summary here, -1 in binary using 2's complement is 3, 4, 5, 6, 7, 8. That's the thing. Okay, so this was all recap. But if you guys forgot anything, just let me know if you need me to go over any steps again. Okay, so I've given you guys this example because it's from here, this naturally builds up to the next example, which I think we've done already anyway, but it was right at the end. So maybe people were getting tired and stuff. So I will redo that part. So how many examples did we do so far? We did 3. Let's make a 4th one. 4th example, let me zoom in a bit. Say, let me just think. So convert the 2's complement to decimal. Okay, so this was probably the last thing we did the last time. And this is, I'm trying to remember, this is a 4-step thing to do, right? 4-step. Okay, so we did one of the steps well, not one of the entire steps, but something that will help for step 1 is we figured out what -1 looks like. This complement binary, right? And we're going to need that. Because step 1, write it here, step 1 is to subtract 1 from the number. Subtract 1 from our original number, which is 10001011. Yeah, the last time we said we do this by adding -1 to the number, right? So maybe I should write that as well. I'll say, in other words, add. Or let me just write it like this. Let's say this is equivalent to 10001011 plus -1. Right, that's what we're doing here. And we know what this -1 looks like because we worked it out above. So let's just use that exactly as it is. So that will be, I'll just do it in the old-fashioned method, the one that works all the time. Add -1. So that's just 1, 1, 1, 1, 1, 1, 1. Add that. So this is how we subtract 1 from the number. What we're doing here is equivalent to subtracting 1 from the original number. So that's perfect. And let's start from the right. 1 plus 1 gives us 10. So that's 0 carry 1. 1 plus 1 plus 1 gives us 11. So that's a 1 carry 1. 1 plus 0 plus 1 is 10. That's 0 carry 1. Then 3 1s is 11. So 1 carry 1. 2 1s is 10. 0 carry 1. 2 1s is 10. 0 carry 1. Another 10 carry 1. And then we're left with 11 at the end. Right? And you guys remember what we do at the end here is that if we have an extra digit, which is more than the number of bits we're working with, so we're working with 8 bits, this is the 9th bit. So we just cancel it. We pretend it doesn't exist. So we just cut it off there. And our answer is just what's left on the right, which is 10001010. So that's the result of subtracting from the original number. Okay, so that's the end of step 1. Step 2. Step 2 is to then invert all the digits. So invert all digits. Which again, zeros become ones and ones become zeros. We get 0, 1, 1, 1, 0, 1, 0, 1. Okay, then step 3 is to convert this number into a decimal number. So that we can do. Okay, so I'll start with that. That's 2 to the 0. 0. It's not 8. That is now let's check. Okay, so if you guys want to use the long method here, you can do that perfectly fine. The long method using expanded form, all that stuff, you can do that. Question. Step 1. Step 1 is to subtract 1 from the number. So subtracting 1 is the same as adding -1. So that's what we did here. So this is the original number. This is -1. So I just added -1 to the number. And using the old method of adding, we end up with this right here. Do you have a specific question?
Yeah, we added those two.
Yeah.
Then the ones that are on
So they come from the carryovers. So for example, 1 plus 1 in binary becomes 10. Yeah, so that's 0 and I carry the 1.
Oh,
Don't stress, we're well ahead of time, so you can ask anything that you want to. Okay, so the last step is the easiest step. Let me just make that a bit bigger. Okay, so step 4 is to just, whatever answer we get at the end here, here we got 117. Step 4 is to just make that -117. So whatever answer we get becomes negative. That's step 4. So step 4, -117. So it becomes a bit elaborate. Usually, if you have a positive number that you want to convert, if you have a positive binary number you want to convert to decimal, it's quite straightforward. It's just a one-step thing. But any negative number, which is written in a negative way using 2's complement, we need 4 steps to convert to decimal. That's what we've just done here. Okay. All right, and that's taken a while to do. It's 10:30 already. Is everyone understanding what we're doing here? Okay. All right, so let me just see what's the next thing we need to do. Blank page. Okay, so we've done that. Do you guys want to try a few examples? All right, let's see. Yeah, let's do at least number 2 and 3. If you have more time, go back to number 1. Actually, you know what? Do all of them. Number 1 is very quick. Let's do all of them. Yeah.
Go back to the,
Yeah, sure.
you think about it, makes part of the complete. That's fine. It's really easy. You're very close, but it is. Apparently, it's like, oh, yeah, it's interesting. Yeah. What if we have let's come on this is cool stuff I'm messing in my house and I'm like, but damn, yeah, if it's really in your house, think about it. Yeah, it's really in your house. Fun ones. Why didn't I say money about nothing sure not going to be there. Nothing sure. I wouldn't do that as something black screen. According to history, it's going to be all the X screen. And the bad thing was, right? Was because there's I know it's true. I think it's a real answer. I'm pretty sure that you might actually write it servers. And kill your last no. Oh, you can try things. And back then, the choice is one of those. I don't know specific. So now you want to try to almost no, we just got to try to almost. You can, but it's. Yeah. Oh, yeah. So who's one of the best expressions? Who's one of the power struggle? I don't know, yeah, it's just making the power struggle. It's all fair and each other. My mind is a function of having yeah, so this was yeah, so I said it means it's the same one is the best just these mention I don't mind. It's my Oh, yes. No, first one. Yeah, 1 second. I will play the second. You carry the one there. Bunch of money spent. You get I got
Correct. Correct to what you says, yeah.
Right?
Yeah.
That's one. Add one. Yeah. What? I'm just going to go on. Oh, I see. Why do you almost being one, I need to save that. This is going towards complementing lessons. Oh wow, now we can realize I was doing that one thing. Let's see your it looks wrong. Must be doing programming, you'll see this topic. In the later Canada scale. Yeah, do your work.
Write the right one.
All the stuff is not needed. Yeah. Previous learning units and stuff, but for programming the stuff you guys will need. Yeah, I don't know why I'm here because I'm not an IT guy. I don't know why I'm the lecturer part here. How can you be the lecturer for this maths programming reason? Sorry, what's the word? How long have you been a lecturer? Oh, this is my 3rd year now.
You still.
I'm still here.
You haven't been here for like.
No, not about being here.
No.
I think like this. Maths in principle.
Oh.
No.
I think it's kind of mechanics. Yeah, but it's good on this. The definition of his homework during I remember
The quantum stuff is so much more interesting. Like, see here we have zeros and ones. In quantum, we could have a process that happens which splits something into 0 and 1 at the same time. So we represent that using what's called a state ket 1/√2 0 plus 1. And that's the thing that exists in reality. It's a strange thing, but it means 0 and 1 are happening at the same time. It's like a more abstract reality, but there's experiments that show that it actually works like this. There's one called the double slit experiment, which if we finish early, I can explain to you guys a little bit. It shows that something chooses more than one reality. at the same time.
So like you should offline, not showing you at the same time.
Well, on the quantum scale, macroscopically it's hard to do, but in principle, yeah.
Not paying attention. Don't worry, not shooting at the same
Let
time.
me take that out before people write that down and think it's work. Like I'll give you one strange example. If you give a particle two choices, it's a quantum particle and there's no noise around. So you send a particle and there's two slits. It can go through one or the other. It always chooses both at the same time. And you check the outcome at the end, it's consistent with something that went through both at the same time. Because if it goes through one, it'll end up either on that side behind one or behind the other.
Yeah.
But at the back, you get something that looks like it went through both, interfered with itself, and made a pattern in the back. So it always chooses both somehow.
Video. I didn't understand.
Yeah. You're doing a challenge for the time. Yeah. Speak the
Oh, basically, this
Quantum.
that's how strong my stress is.
No.
Let's just stick here. Okay, we'll stay here. Let's stick here. Okay, guys, I think we can at least do example 2 before the break. Some people having trouble with example 2? Yeah, little bit. Okay, so let's do it. So example 2, this was a 4-step thing, right? 4 steps. So step 1 is to add a binary -1 to the original number. So I'm just going to do that like this without any writing extra stuff. 1001100. That's the number. Add a binary -1 to this will just be 11111111. So that's how we add a binary -1. Right? And then we go through the old-fashioned method of adding here, which I will do slowly in case I'm losing anybody with this one. Okay, so on the extreme right, I have a 0. Maybe I should recap the rules in case anyone's forgotten them. The rules are if you have a 0 plus 0, that is 0. 0 plus 1 gives us 1. 1 plus 1 gives us 10. And if you have 3 ones added together, you get 11. Those are the only possible things that can happen. Okay. So again, it comes back to counting finally.
That's why I looked at you wrong.
Yeah.
Look at the rules.
You guys are looking at me like I'm writing this for the first time. Yeah.
Plus 1 if you're gonna tell them 10.
Yeah. Don't take this for your other modules, please.
What's the answer? Yeah, you also. I just want. This is not. Yeah, I just want. It's in minus. No, it's not.
So these are the 4 things that always happen. That doesn't change. Minus 12. I didn't finish the example yet.
No, it's fine.
For 1. I'm not sure what we're talking about at this point. Oh, number 1. Oh, okay. Maybe I should. I'll do number 1, then we'll take a break. I'll continue with 2 afterward. So for number 1 is straightforward. All we do is every single bit here represents the power of 2.
Yes.
Right, so this is 2 to the 0, but it doesn't exist because there's a 0 there. Right, 2 to the 1 also doesn't exist. 2 squared is the first one that exists. Right, that's why I put that here. After 2 squared, 2 cubed also exists, so I put that here as well. And nothing else exists, they're all zeros. So that's why we got only those 2. Yes.
So Phil, why didn't we?
Yeah, you have 3, right? Yeah, so if you add the -1, then invert it, and then.
That's because the first bit indicates whether the number is negative or positive. Because the first bit is 0, remember the simple sign that applies here as well. So the first bit is 0 means that's a positive.
Yeah, guys, not studies.
So converting a positive number is just the straightforward method that we always do. We don't have to do the four steps. So if the number is positive, we'll go through the long procedure. Okay, as I said, guys, when we spoke about the last one, it was right at the end of the lesson. So if you forgot that stuff, it's okay. Right? Maybe let's take a 15-minute break here. Okay.
Be generous, guys. That number is 0. You don't class number. The third number is 0. You don't get negative.
Yeah.
Okay.
Yeah.
That's all.
That's good. Yeah. So the first number is 0, you just do the simple method. If the first number is 1, you do the 4-step method.
Okay.
Okay.